This video is based on the following sources.
The theory of physics has no clues for why there is so much more matter in the universe than antimatter, which is so scarce in nature. This so-called baryon asymmetry is considered a mystery, since according to existing theory, the Big Bang should have created equal amounts of matter and antimatter, which would interact with each other and annihilate. To trace the reason for the dominance of matter over antimatter, we shall borrow from the theory of electronics. We shall particularly refer to a specific deep symmetry that we introduced previously, in videos 3 and 4, to hold between the gravitational and electromagnetic interactions. In the gravitational case, we introduced the reason of existence of an inductive-like phase shift between the curvatures of the time and space metrics over the cosmic scale, like from a black hole, all the way to the distant universe. The Tsikuta's model particularly determines that the cause of this shift, which associates to the Higgs field, has a very deep analogy to the cause of an inductive phase shift between the alternations of voltage and current in an electric circuit. In the case of the electric circuit, power equals the product of voltage times current. In this case, since the voltage and current alternate, power oscillates as well, and this oscillation may be represented in the form of a curve. When a phase shift exists between the alternations of voltage and current, and this phase shift is not too large, the power curve gets to exhibit larger positive and smaller negative parts.
It similarly applies with the energy product of the potentials arising from each of the curvatures of the time and space metrics over the cosmic scale, that the new model introduced to be subject to a phase shift between them of extent equal to the Weinberg angle of 30 degrees, as presented in video 4. Due to this phase shift, the energy product of these two potentials exhibits a similar form of waviness, having larger positive and smaller negative parts. The larger positive area in this case signifies accumulation of more energy in the form of matter, which translates in a far larger number of conventional matter particles in the universe. The smaller negative area signifies accumulation of less energy, which translates in a far lesser amount of particles inhabiting that part of the universe. But, what could the negative sign designate in this case? Let us here assume that it indicates accumulation of antimatter particles. In such case, the smaller size of this negative area would suggest that there should be a lesser amount of antimatter particles than matter particles in the universe. But if this is indeed the case, then where are these antimatter particles located? Why don't we find antimatter anywhere around us? And when antimatter is created experimentally, it very quickly decays? Notice that in this cosmic region, the graph is designating the time metric to be taking negative values, as if time was moving in reverse direction. This is in line with the new model's prediction that the curvature of the metrics of space and time over the cosmic scale follows an extensive waviness, which in certain areas reaches into negative values, as we shall elaborate in the next video. Speaking of the time metric, that Tsikuta's model makes clear that negative time has nothing to do with things moving backwards, or time travel like in movies. Cosmic regions where time moves in the negative direction are specified to concern areas where interactions take place normally, without contradicting any laws of cause and effect, subject to a very particular condition, that such regions should be stable habitat for antimatter particles and structures only. The model actually associates these cosmic spots to existing, indirect observational traces of astrophysics, as the manuscript of this work references, and shall be addressed in the next video. These cosmic spots, which appear to contain antimatter only, should not be inhabited by conventional matter, as conventional matter should reach stable form only in regions where time moves in the positive direction, where it exists in larger quantities, as the larger area of the graph indicates. This concludes the reasoning behind the dominance of matter over antimatter in our cosmic neighborhood. In the next video, We shall additionally introduce what holds for regions where it's the space metric that takes negative values. And we'll address how such regions appear to particularly relate to behavior of exotic particles, like neutrinos and antineutrinos. In relation to that, we shall also address that these regions of negative space metric allow for a new interpretation to the negative solutions of the Dirac relativistic equation, linking the negative solutions to these exotic particles, and not to antimatter as of the conventional assertion.